In the second session, we're going to discuss a little bit about language-oriented programming, but first we're going to play with a real-world DSL. And this is DSL for Forms I talked a few minutes ago. And I'd like you all to clone this repo. And hopefully all of you have Node installed version 10 or higher. If not, you might want to install it. It's OK if you don't want to. And you just cd to this forms directory inside that repo and run makewatch, and hopefully all of it installs automatically and runs. Paul didn't have npm installed, so if you installed Node using apt-get or whatever package manager you have, you might also want to install npm, which is Node's package manager.
Sorry, which version of Node?
10 or higher, yeah. Because PureScript dropped support for Node 8 and 9 in the last version.
Yeah, apps says, I need to just go grab one.
Oh, sorry. Did everybody clone the repo already? Okay, I'm going to just switch things here. I'm going to do it here too. Okay. Should have duplicated my screen. Okay. I'm not going to have this use full screen. Y'all should be getting this screen if it all worked. Did it not work for anyone? Worked? Cool. If anybody has any problems, please speak up. Sure. What?
That's fine. Can't actually run Node with watch.
Does it? But if you open the browser at localhost, it doesn't work. Oh Jesus! Which version of Node do you have?
11 something.
Oh,
Yeah. I shared my
what?
library. And the info is
Yeah. So 11 is not LTS, but that should work. It's like it's not LTS, so it can contain bugs. It's perhaps that, I'm not sure. I'm sorry, I've never seen this in my life. I'm sorry. I can't help too much.
It usually means too many file descriptors, so just gonna restart.
So, well, some of you leave it installing there because it can take some time and it can heat up the space a little bit too. Let me just show you briefly this small form. It has just these two fields where I can type, like for example, an email. I can type something here, and as soon as I type something that is not an email, it warns me. And if I type something that is not that is an empty string, it tells me that email is required. And as soon as I type a valid email, which I have said is anything that contains an @ symbol, but we're just going to complete the email for fun. And if we provide here a password, we're going to see that we have a valid value here, and it outputs to us the valid value. If I give it something that is not a valid value, it just outputs to us invalid form. Right? It's pretty simple and all that, but the cool thing is that it... okay, I'm already in Chrome. Oh, why the shortcuts don't work well here? Yeah. So the cool thing about this form, did anybody have any problems? Did it went all okay? Okay, cool. Nice. Yep. Yeah? JC? No, none.
It's like saying that I don't know how to install JC on your system. Like I'm running NixOS, so it's not an issue. But like,
Does it give you a GHC error?
I don't understand what this tries to do.
One sec.
Like ensure that appropriate JC is installed.
Excuse me, 1 second.
I
Thank you.
guess it might not like know how to, or like it maybe the pure script
Oh shit.
doesn't run, but I do have that on my.
I didn't know that. It compiles it. It's probably like the pure script binary is probably not available for his system, so it's
Yeah, but I
trying
do
to
have it on
compile
my,
it.
like global path.
Yeah, I mean, I would just delete PureScript from like that node packages.json and then just install everything else. Like,
Yeah.
what else do you need in this?
I just need pure script
Okay.
and like
I guess
NPM.
I have the pure script setting on the global path. So
Uh-huh.
if I just remove.
Oh, are you using 013 or
013.
13?
Yeah.
Okay.
Yes.
Then it's just might as well just delete it from package.json.
Yeah.
Then it should work.
I also believe that there's lack of the Lumi components in dependencies, probably because when I just
But did you,
npm I run npm start.
could you please cat or bat bower.json?
Bower. I don't have Bower.
No, but that's not a problem. It's installed. No, bat bower.json, not just cat. See the contents. Yeah, it should be.
So I should run Bower somehow because I just ran npm install.
Did you run make?
No.
Yeah.
Make.
Yeah, make. Okay, then make watch. I probably forgot to include a command there. It's make watch. Sorry. Makes space watch. And it runs.
Thank you very much.
Sure.
Localhost 2000, nice.
Yeah, one thing I forgot to say is that if it works okay, you can like navigate to your browser to localhost port 3000 and you're going to see the example there.
Cool. Works.
Nice. So right, for those who did have problems, like it's not strictly necessary to do this because like it's just so we can play with it a little bit. So I'd probably recommend that you pair with someone so you can like play with it with someone. I don't think I've mentioned this, but it couldn't help also to have like editor plugins for PureScript because we're going to write PureScript code, but it's like the errors pop up in the terminal anyway if you write an invalid code. So like the goal with this example, like what you have seen there, this form that I've showed here, it's like we have this data type registration. Suppose we have a system and we want now to have a registration page, right? So we create like this registration data type that we're going to send to a server. and it has just these two fields, like email and password. That's presumably all about you need to register inside the system. It's not what everyone does. Everyone should just do this, not ask for your address. But suppose we have a system that just needs your email and password to register inside it. And an email is an email address. The email of a registration is an email address, which is just basically a non-empty string with, and we have defined a way of creating an email which validates it beforehand. And the password is a non-empty string. For those who are not familiar with PureScript, like this new type here is correct, even though this has two fields, because this thing here is a record of its own. Like PureScript has first-class records, and this means that records are types, right? So like this thing here, this email is not a field accessor of the registration type. It is like these two things. This record is a type of its own. So if we like unwrap this constructor, we're going to get a record that contains these two properties. This is a very defining feature of PureScript. By the way, if anyone has any questions about syntax, about anything that I haven't talked about anything at all, especially about PureScript, because we're going to see a little bit of PureScript code here, please speak up. So the definition for that form that you're seeing probably on your screen is just this here. It's pretty declarative, and for those who are not familiar with do notation, like do notation is syntactic sugar in Haskell for sequencing monadic actions, and that means like we can write sequences of bindings like this, for example, where we have email and this left arrow, and this basically means that we extract the value that's inside, that's produced by this context, by this effectful operation, contextful operation, whatever. We extract it, and from there on, we can use it below, right? We can get values from effectful operations and use them inside the remaining effectful operations. A do syntax in PureScript is special syntactic sugar for applicative, right? So when you have an applicative, you're not able to do things sequentially. Like you're not able to affect the context, the effects based on previous values. And a do notation in PureScript, for example, guarantees that. Like all the things that we bind here, like for example, email and password, we're not able to use email inside here. We're only able to use email below the in clause, right? Because basically that's how applicative work. If you don't know how applicative, how monad work, don't worry. Like just abstract this and think that it's syntactic sugar and that it should follow this basic rule here, this basic syntax. Okay. So what's happening here is that we're building a form called registration form. Its type is form builder. Ignore this underscore. I'm going to talk about it later. The form data, like where we store the data that is displayed in that form when we type inside the fields, is this type synonym called registration form data. I'm going to show it. And the final result of this form builder is a registration. It outputs a valid registration type. And I mean valid because like there's no other way to construct a non-empty string besides it being a non-empty string, right? Because if you have this function like a non-empty string, I believe I forgot the name of it, but it produces a maybe non-empty string. But here we're guaranteed to have a non-empty string, right? And this, in the same sense, we're guaranteed here to have a valid email address. So this thing, it can output to us this validated result. And the way we're doing this here is like saying that email, the name email, gets bound to the result of this thing here, right? And this thing here is also a form builder because as we have seen, like syntax trees and the syntax part of our language, it's based on data and combinators so that we can like build more complex expressions based on simpler expressions. And this is exactly what we're doing here, right? Because this thing is a form builder, so everything here inside must be a form builder, right? What is after the equal sign must be a form builder. And since we're not like using, presumably from what we presumably can see here, we're not using any other types, like all of these things, this thing here, at least, it produces a form builder. So what's happening here is that we're indenting this email. I can't show these things in parallel. I wish I could, but we're indenting the email field. I should probably go the other way around, actually. Like, email is a text box first, right? The form field for email is a text box. That means that it is a form builder that stores its data as string and produces a string, right? This form field is validated by this rule called non-empty. This string email here is just for like UI purposes so that we can show like email is required when it fails. After that, it's validated with this rule is valid email, also the email string here, so we can output it correctly in the UI. It focuses in a special property of this registration form data, which is defined, I think, if I did it right in the next slide. Right. This registration form data is what describes the type of what exactly we're seeing in the form, what is seen in the UI, and what exactly is stored in like the form data, the internal form data. It has two fields, email and password, and as I've said, like PureScript has first-class records, so this is a valid type, right? It has two fields, like an email, which is a validated string, and a password, which is a validated string. Ignore this validated, this is just like internals of the DSL and how it works. It means that you have a validated field, and that this field has some special properties. But we need to now tell our form that, our whole more complex form, that this individual field for email, this text box, it changes only a single property of this record. So we pass in this underscore email value, which is a lens. A lens is basically a thing that lets you focus on a specific part of a larger data structure. Like suppose you have a tuple, and you want to focus only on the first element of the tuple or on the second element of the tuple. If you explode this concept, you can get lenses that focus on any other structure that's kind of isomorphic to a tuple, in the same sense that this record is isomorphic to a tuple of two values, but we identify the first one with a label, okay? So, and this just transforms what is below here, which is a form of string, to some other value, right? Email address, because these things produce email addresses. It focuses on this email property, so we can use any record that has an email label with this. And then finally, just adds a pretty label to it, to the left side of the field visually, and required here is another argument to indent, and it adds that red asterisk. The same thing is valid for password. And finally, after we've bound these two values, these two names, email and password, we can finally construct our registration, which is comprised of email and password. This should actually be a column here, like email, column, email, but PureScript accepts this, like the syntax is showed, like if you have a value and the field name is the same thing, you can just write email and password like this, right? Does anybody have any questions at all, syntax-wise, anything? Sure.
I'm looking at the code. What does the underscore in PureScript do?
Oh, no, yeah, the underscore.
The definition for email has an underscore there, but, oh, yeah, right.
Yeah, okay. So, yeah.
Never mind.
1 second, I'm going to talk about it. Does anybody have any questions? Sure.
The dollar sign is the same applied from Haskell?
Sorry?
The dollar sign is the same from Haskell?
The underscore?
The dollar sign.
Oh, the dollar sign, yeah, it's the same thing from Haskell. Yeah, anything that's like a little bit obvious, you can assume that it's the same as Haskell because PureScript is a lot like Haskell. Anybody has any questions? About this syntax-wise, I don't know, semantic-wise? Can it?
Sorry.
No, please go on.
It's the third argument to indent always a lens?
No, it's just like the third argument here, or the third argument, the rest of it.
The focus, like, I mean, do you always need to pass like a focus and then a lens?
Yeah, so the third argument to indent, like all the arguments to these dollar signs, they're form builders too, right? So focus, for example, it takes in a lens and it takes another form builder here and produces another form builder. All of these, like indent, focus, validated, password box, text box, all of these produce a form builder. And with the exception of text box and password box, all of them take a form builder as the last argument. Right? So these are all combinators like validated, focus, indent, and even text box and password box, because they're going to see the definition soon. These are all combinators. These are things that are defined outside of our syntax tree. And like they take in a valid syntax and produce valid syntax, or maybe they just produce valid syntax from nowhere. forgot what I was about to say, but it's okay. So, yeah, can everyone like understand the definition of this, like the declaration of this? Can anyone assign some meaning to seeing this expression and like guess what it does? You probably can guess what it does because you've seen it beforehand, but I assume that you could also, after a short explanation, guess it. So just so you don't get lost in syntax when looking at the code, like to define a lens for a specific field in PureScript, we use this function lens. We pass in an accessor, which is like _.email. It accesses is a function that accesses the email label of any record, right? This underscore is like anything. And here's the same thing, because PureScript has this record update notation, just like in Haskell, you can pass in a record and open the braces, pass in a field label and a value, you know? But this is like the same thing, but with underscores where we need the values to be, okay? This is how you define the lens to be used here. I don't expect everyone here to understand all of this, like how does this work inside, like how the lenses work, how does record update notation and syntax work. I just expect you to be able to use this when we're playing with this. And I've defined also this is as valid email validator, which is outside of the Lumi library. And okay, yeah, just like replacing the lenses inside, we get this, right? So this is valid too. And okay, I'd like to first ask you to, if you'd like to like change a few form fields there, try to change a few form fields. I don't know, add another form field, use your creativity to, I don't know, perhaps add a name field, first and last name. You might want to, oh right, another cool thing about PureScript is that it supports holes too, typed holes. So if you want to, for example, type in an expression you don't know what belongs there, you can just type in question mark and the name, like question mark X, and in the terminal you're going to get an error that says like the type of X is this thing here. You had a question? Excuse me? You had a question?
I think it was answered because I was wondering if this chain of dollar signs actually is like composing those functions.
Mm-hmm.
And basically the type just the line and everything.
Exactly, yeah. Everything like is after the $ returns a form builder, so that the combinator above it can use that form builder to build another form builder. Yeah, another thing I forgot to mention is that there's documentation available for this library. Just 1 second to whoever was looking at it. So if you go to this repo, you can probably, there's probably going to be a link to documentation per suit there in the README. So you can get documentation for all these functions that are used in the library. And like if you don't want to copy the link, just type in PureScript Lumi components in Google, and it's easy to find. If anyone has any questions, is facing any problems, like please ask. And I'm going to give like 5 or 10 minutes so we can play a little bit with this, and then I'm going to do something here too, and try and build some more complex forms. And yeah. Then after that, we're just going to discuss how all of this works. If anybody wants any help or anything, please ask. And right, one thing I forgot to say is that whenever you save the file, Webpack is going to compile it. So if you don't have any editor plugins that show you some errors, you can check in the terminal if you've got some errors. And if it works, it's probably going to refresh your browser automatically. If it doesn't refresh your browser automatically, you probably want to try it yourself manually. Did you get it to work there? Did you get it to work? Oh, cool.
I just have to remove the
Nice.
dependency from
Oh.
to change the
Cool. Sorry about that.
Yeah, no.
Want some help there?
Yeah, try to use just to add another one here.
Is valid email to string?
And I
Right.
tried to use a typo and then I got this useful message.
Oh, yeah.
It's fine.
Yeah, it makes sense, but like it's not helpful, right? Oh, you're right. One thing I forgot to mention. 1 second. It's just composition of functions in PureScript is not with a dot. It's with like 3 less than symbols, like 3 less than symbols. That's function composition in PureScript. I think that's the only thing we're going to use that's different from Haskell, probably.
So should we take that?
Right, so one thing is that is valid email, it produces an email address, right? Validator is basically like, I should have added that type here explicitly, but validator is like non-empty string to either string email address, right? So this thing...
So it's kind of, okay. Anyway, I was trying kind of
Yeah, sure, that's perfectly valid. Like, if you wanted to compose these things, you probably would like to use a monadic composition, right? Or maybe like functional composition, like mapping over the result, because it's an either. Sorry for touching your screen. Yeah, sure.
You wanted to add a password confirmation field and then see if they're the
Yeah.
same, but then you cannot
Yeah.
access the
We're going to see that.
Yeah, cool. So
Okay, so
then
you
you need
need-
to define the
you-
validation on the registration or something. Like some
No, you must use an abstraction mechanism so that you can reference things here inside, right?
Yeah.
You need to reference things inside and use the same, because if you did the validation here inside the registration while building it, you'll not be able to use like the validation messages, for example.
Oh,
They will not show up
Yeah.
because they're defined here for form builders only.
Okay.
So what you need is an abstraction mechanism so you can reference things here inside, right?
Yeah.
And there's 2 ways to do that. Because since we're in applicative here, right, you can't reference past values.
Yeah.
So there's 2 options for this. You can either use a monad here,
Yeah.
or you can use higher order functions, right?
You have an environment or something.
Yes,
That
exactly.
has it in.
And you have an environment here, this registration form data. Like you can reference what's been typed, like the actual value of the thing, right? That's been typed inside the form.
Oh, you have, because you focus it here on the lens, you have the, okay.
Right? So you can use something. If you want to try, you can try the f.with value combinator. If you want to search for it, it's with value. Yeah. The types are hopefully helpful, I think. They're not.
I need to get used to this.
Sure.
So I got an extra form working without issue. I'm trying to figure out how to do non-required. So figure, add an optional flag down here instead of required. But when I do that, I get an optional tag, but the form still tells me it's still required. So I
Yeah.
assume there's a type level thing I need to do up here for it to...
No, actually, so the thing is that this optional required thing is just visual, right? This indent combination is just visual.
Got it.
So if you want to make it optional, you have to remove the validated thing, right?
Oh, you can't validate it all. Okay.
Yeah,
interesting.
because it's not validated, right? So you're going to get an error from that because the type says that it's validated, but it's not actually being validated. So you have to remove
Can't do
it.
validated string.
Yeah.
Got it.
Yeah, if this again?
Let's do.
All right, yeah, of course.
Oh, yeah.
Sure.
Because it's telling me
Oh.
do, and yet looks right.
Let me see. Was it working before?
Yeah.
Okay. Just so. Whoa, that's weird.
Is that
Like,
a white space thing?
yeah, I wonder so. Like, have you added any invalid white spaces there?
Like tabs mixed in. Let's see.
Yeah, I do use tabs.
Oh, it was 10.
Okay, yeah. Just only uses spaces, so it's that. I believe it's that. Sure.
So, because I see that there's like a required
Uh-huh.
indent, which like I could set as optional, for example. But then I also saw that, like, because I can put optional here, and then also say that I'm validating that it's non-empty.
Exactly. Yeah, that's a failure of the DSL. Yes.
Okay.
Like
So
this thing is only visual, right? So this is an example of bad modeling too. Like the DSL is not perfect at all, right? So it has some correctness problems too. It has some invalid states that we can achieve using these the set of combinators. I'm going to talk about that too.
Okay. But in any case, this line is pretty much driving the UI.
Exactly.
And this is the logic behind the validation.
Exactly.
Okay.
So if you could do like required, but a field doesn't have any validation. We have a few tickets in our repo for that, with some fields that are said to be required but are not.
Okay.
So yeah.
Thanks.
Sure.
What's case matching?
The same as Haskell.
Oh, perfect. I'm trying to use index of and split at to check that there's a non-empty string on each side of this, just for for
Yeah.
fun.
Yeah, it's the same thing as Haskell.
Cool, cool.
Case off. And one thing you might want to pay some attention to is that it doesn't support tabs. Like it must be all spaces. It's white space sensitive. Like if you're writing tabs there.
I really try not to write tabs.
Okay. Cool.
Good language decisions.
Sure.
This is what happens in Emacs.
Whoa.
It says version mismatch.
Expected to solve it one. Okay.
That is
so
pure script version.
yeah, that's probably because your plugin for Emacs expects that version, but you have 0.13 installed and it was compiled with 0.13. Right? So one possible solution, if you want to use the Emacs plugin, is to just go to bow package.json and change the version there, because it's going to work with 12.12, right? And you npm install again, it's going to work. Really? Yeah.
Okay, first you make your literal segment, then you make your parameterized segment. It has this row type thing of row. And I union them when you join them together. So the thing is literal appended to
Very
Apple,
nice.
where my special literal is I do the union.
Oh, cool.
I guess it works.
Yeah, that's nice. So just so we don't run out of time, like, did everyone got something working there? Did you understand like the basic functioning of the library of the DSL? Okay, cool. Did it feel like writing a language or something like using a language at all? It must not. And yeah, so someone pointed out that it is indeed a problem. There is indeed a problem with the DSL. There are many, actually, but one of them is, for example, that this required thing, it's just this indent combinator just drives the visuals, the UI, right? So we could have added like that this field is optional, or that this is neither required nor optional, which means that it's optional, right? But, and while keeping the validations, and that would have been like a domain error, right? But it would have been just pretty much valid syntax and a valid form as well. So this is a problem with the DSL, with the interpretation of the domain, and also with how exactly it's modeled, right? We could fix that. It's something that is worth fixing, yes. So presumably everyone got it working, so I'm going to show also something that it's possible with the DSL, and it explains a little bit about how to add some more capabilities using the constructs we have in Haskell. Oops. So Lawrence tried to add a password confirmation field, but that was not possible because like, how exactly are we going to match the password confirmation with the password if we cannot reference the password itself inside this a do in block, right? Because it's applicative notation, we cannot reference past things here inside. We can only use them here down below the in clause. So one possibility to do that is to add an abstraction mechanism to the DSL. And by abstraction, I mean like referencing things like functions do. Functions are abstractions in the Lambda calculus and all of that. So we need to have access to an environment from which we can extract some values and write a valid form builder for that to use as a field here. We could also like use monads here, but I'm not going to show them, but this language supports also monads, but they have a little bit of a different behavior because if the previous field is invalid, then you're not going to be able to access the effects that are produced by the rest of the form. So you're not going to see the fields actually, right? The subsequent fields only become visible when the previous ones are valid, when they can produce a valid result. So one possibility to do that is to use this with value thing here, right? And with value, it's basically an abstraction mechanism that lets you reference things here. And PureScript, like it has block arguments by default, so you don't need the $sign here. So, and this with value combinator, it allows us to reference the form data, that first type there. So you can access the password here and mind that this password here is exactly like it's the string. It's not the validated result, that validated password result. It's the validated string. And yeah, this thing is wrong because it should be from validated here, but I'm just going to edit the slides here so you can get it to compile if you want to. Okay. Now, hopefully this works. This form field now, it has access to something else. It has access to this extra environment. And this is a nice example, I believe, of adding capabilities to a language by using constructs of the host language. Because until then, we didn't make use of any higher order functions. This can hopefully show a little bit of the power of functions, right? When writing DSLs, for example. You can access extra data that you could not normally reference from inside the DSL. And this just basically is a validator that checks whether the two passwords are equal, right? If they are, this should have been from validated here too. This from validated function is just something that unwraps a validated type, validated value. So yeah, if the two types are equal, we just output the password confirmation. If they're different, we just output a message, passwords do not match. We're not using this value at all, right? So we add an underscore here. And that's basically it. Hopefully it works. Does it work, Lawrence? Did you try that? From your uh-huh? Okay. From your uh-huh, I thought.
Where do we import with value from?
Sorry?
Where do we import with value from?
With value is the same thing as f dot with value. It's in the same lumi.components of form. Yeah, so I'd first briefly like to talk a little bit about how does it work now, because I'm a bit running out short of time. Should have timed this better. But how does it all work? If any of you have peeked into the documentation of the library, you probably have seen this type form. It's a little bit different here in this first slide, but I'm going to talk about that. It's defined like this, right? It is parameterized. Imagine there's an underscore here because we have seen this underscore before. But this form builder is parameterized mainly by two values, by two arguments. A value, which is the form data itself, like which data the form manipulates, which data structure does the form manipulate, and the result, which is the validated output type of the form. And its definition is basically that you take in a value and you output a record, which is basically isomorphic to a tuple, right? Where the first one is added, and it takes in a function that is just a callback that effect is just IO in PureScript, and unit is just the empty tuple. And this is just an on-change callback, which is passed to this UI, which gets rendered in the browser, right? And this UI has access to this on-change callback, so it can effectively change the value that is contained inside the form structure. And validate is just a valid result for the form. And it has, obviously, an applicative instance. And this applicative instance, it combines the UIs that are generated with a monoid instance. So this UI needs to be a monoid. I didn't need to add a constraint there because it's implicit, but I should have illustrated that. So in reality, it also takes another type argument here, which is props, which are basically global properties of the form that can be combined. I'm not going to discuss about them here. But if any of you are familiar with monad transformers, and not all of you need to be, but just out of curiosity, this is isomorphic to just read a T of tuple props and value, write a T of form UI, where form UI is this thing, because functions are monoids too, right? Because if the output of a function is, the result of a function is a monoid, the function is a monoid too, because you can just write another function that takes in an argument, passes it into the two things you're combining, and then combining the results. And with a maybe by the end, right? This is isomorphic to this. Perhaps it gives you a better intuition for that, for those who are familiar with monad transformers. And it has an applicative instance that can also be derived. So right. This DSL has obviously a syntax and semantics. For the syntax, we have a bunch of combinations that can be used. And it all starts, or it all ends, with some form fields, which are the things that we effectively want to render in the screen. Where do we get the user input from? And we have a bunch of those. Text box, password box, switch are just an example. We have a bunch of combinators too, like indent and focus, which you've seen. And they basically take in a form builder also and produce another form builder as a result. They're just means of combining things in our language and producing some more complex forms. We have also validated and with value, which you've seen, which are some more complex combinators that also change the type of the form structure we're editing and of the result type. And as for the semantic interpretation, if you've been curious enough to look into the other files of that repo, you probably have seen a components.app.pers file, and it makes use of these build and revalidate functions. Build is basically an interpretation of a form builder. You can see it takes in a form builder and outputs another value, and it basically interprets a form builder into a React component, right? Into a visual UI component that we can then render into the browser. And revalidate takes in a form builder and outputs a maybe by the end, which is basically an interpretation of the form as this function that you can supply the value and the props to it and then get a valid result. This is just basically validating a form given that you have a set of values that have been inputted into that form. You can also simulate, for example, the fulfilling of a form with this interpretation. Does anybody have any questions so far? Any? And always? There are no stupid questions. Okay. So moving forward, and finally get into language-oriented programming. We also have multiple DSLs for building more complex forms. So as I've said, we have, for example, a small DSL that integrates really well with that one for building like monadic forms in which forms can be sequential, like they can depend on each other. We have a small DSL for like building wizards, which are forms with multiple steps, so that you can like click a button and go to the next step of the form, and it all keeps tracks of that and the types of the values that you can reference, etc. And we have, yeah, this one here. It's a wizard. It has, ignore the syntactic definition. I just wanted to, for those who are familiar with free, it's defined in terms of the free monad. And it is a monad, right? So we can effectively sequence things and depend on past results to shape the next steps of the form. And it has this basic combinator here that takes in a form builder and turns it into an element of a wizard. I should have added also the interpretation, but it's basically the same thing as build for forms. We have this small DSL also that is used for building tables within forms. So if you have seen the example right in the Lumi site there, you've seen that we have a small table for pets there in the example, and it's built using this thing here. And it's basically the same thing. Like you get a way to lift form builders inside tables, and you have means of combining them with the applicative instance as well. And finally, you can revert back to a table form builder and have a table field inside your form. And by all of this, you can see that it's basically like you have a bunch of languages and all of them integrate together, all of them talk to each other. And by that, I mean that we have some means of lifting languages, lifting some terms of a language into terms of another language, and then a means of interpreting terms of a language to terms of another language. And when you're talking about language-oriented programming, it's basically that you have a system of languages and they're all integrated, they all talk to each other, and you basically have an interpreter from a language A to a language B, then an interpreter from language B to C, and etc., and it goes on, right? All the way down to perhaps the I/O monad. So the basic technique for language-oriented programming is that you design a core application logic, and you write the application in that DSL, and then you build interpreters to execute the problems in those DSLs. But it could be also comprised of multiple DSLs, and it all boils down to the same thing, right? And yeah, it's basically also like that you can, if you have this language-oriented programming mindset, you'll always try to understand your business domain and try to express it in terms of a language of a DSL. Whether it be an embedded DSL or an external DSL, whatever, it's basically like you have this tool, which is a DSL, and you try now to express things, to frame things in that. And your capability, your capacity of like, your ability of abstracting things, it depends directly on how exactly you're going to split things together. And your ability also to split things together depends on how exactly you're going to join them together back again. And so we can arrive at this nice isomorphism that language building is domain modeling, right? A programming language problem is a domain modeling problem in some sense. And I really like this quote also by Matt Chan. As well, like it says that you cannot know what the DSL will be ahead of time, how to evolve it alongside the concrete implementation. So like this whole example that you've seen of the DSL forms we use at Lumi, we have not come up with that by night and the next day we were using it. Like we had to have a problem first, and then we tried to solve that problem in a bunch of ways, and eventually we arrived at that solution because we saw that we had a language there, we had something that could be modeled as a language, right? And we saw that a language would be suited for that, and that would be useful, that would be ergonomic, and etc. So it's basically like with any abstraction tool, you cannot like guess what things will be up front. You have to experiment and try and guess at some point.